Welcome to Beyond Next, Altimetrik's own podcast on all things digital. I'm your host, Arun Kumar, and today we have an exciting discussion with Vipul, a leading expert in data engineering and management. With that, welcome to the show, everyone. As we all know, AI is becoming the buzzword today, where every enterprise is attempting to do something new with AI. The conversations around artificial intelligence and machine learning are pivoting towards how value can be created for businesses in various forms. But foundationally, when we talk about artificial intelligence and the use of AI, it is very apparent that data is fundamental and foundational to all those activities. Today, in an episode that we call as Data in Motion, we are going to explore the latest trends, innovations, and challenges in the world of data. With that, Vipul, welcome to the show.
Thank you, Arun.
All right. Vipul, we've over the course of the next few minutes, we will talk about how data has evolved and data engineering has evolved as well. Maybe we will start with data engineering to begin with itself. You and I have been in multiple engagements where the construct of data engineering has itself changed over the past 4 to 5 years. Why don't you talk us through some of the biggest transformations that have happened in the world of data engineering?
Sure. Thank you, Arun. Data engineering has evolved over decades, right? The fundamentals of having the data in a tuple format to an RDBMS to a data warehouse, and now the onset of data lakehouses, as we call them, has become the standard trend and approach for the onset of the AI, which is coming in. Now, for an AI algorithm or a model or a service to connect to this data, you need the data in multiple forms, not only in a structured, you need it in semi-structured, in unstructured, whatever is available information becomes valuable for these data models to absorb and then convert it into information. In that context, lake houses has become much more prevalent, where the data is not only structured or semi-structured as in a data warehouse, it also has unstructured data for the AI models to execute and absorb this information for better use. To the extent the pipelines that we are building today to bring in data are also becoming very diverse. It's no longer only structured data pipelines, predefined pipelines. Nowadays, the pipelines themselves have become intelligent to bring in information which may not require an engineer to rewire the pipeline or recode the pipeline. So the pipelines have changed, the way we are storing data has changed, and hence it helps the future of AI to become much more faster in terms of what it can deliver and grow it in a way that it can become much more relevant to the business. So these are major shifts we are seeing, Arun. We are also seeing a lot of AI into the data management that we'll talk as we go forward. These are two major trends that we are seeing that's changing.
Yeah, great, Vipul. And I think we will talk a little bit now about exactly what you're talking about, right? One is about getting that data, engineering the entire pipeline infrastructure to be able to bring the data onto a common place. But now there are a lot of conversations about real-time data processing, especially in the construct of unstructured data, various file formats, various data formats, and so on. Can you talk a little bit more about what real-time data processing entails right now?
Sure, Arun. Historically, when we used to talk about real-time data processing, we used to talk about IoTs or transactional systems from where the data used to be brought into an analytical platform, and then a report or a subsequent service would consume this data. Uh, this context remains true even today, but the thing that gets added in the onset of the new age systems that are going to consume this real-time data is the latency doesn't change much. Latency is still the same, very short cycles of data coming into the system, but the type of data coming in has become much more different. Historically, we used to take an unstructured data, convert it into a semi-structured or structured data, then move this data into a analytical platform for subsequent usage, and we used to call that real time. now the unstructured data directly gets stored as unstructured data, reducing the time of this conversion and standardization. And AI models are able to tap into this unstructured data directly, which means the conversion time taken historically has vanished in many cases, if not all. And that's another dimension that we are looking. And when we say real time data processing, now it's very, very real time than the near real time that we used to talk around before.
I think it might be beneficial now to pivot into the role of AI in data management itself, because that's fundamentally the construct of this podcast as well. Uh, can you talk to us, Vipul, on how AI has changed the way we handle data?
Sure. When we say handle data, right, this is very interesting that you're asking, because historically there used to be, and I'm going to bring in the engineering aspect of it here also. Historically, there used to be a data pipeline engineering team which builds pipeline, brings the data, stores it. Then there's a data management engineering team which does the master data management, reference data management, data quality, and so forth, certifies the data, and then there's a service or a BI team which absorbs this information. If you think of this construct, and with the onset of, for example, a conversational AI application. Now, conversational AI application needs to understand the language of human, needs to understand the business context, and this re-emphasizes the semantic layer. Now, if you bring in a semantic layer is what? It's the amalgamation of your business terminologies, taxonomy, ontology connected to your actual databases and data attributes, which means no longer you have to get confused between customer underscore ID or cust underscore ID. You have, as an organization need to define customer identifier as a terminology, and this ontology of connecting these to all your field is defined in the semantic layer. Now, how does this change, or what does this impact the whole business reality for using AI is? There used to be a time when you need to have a army of engineers understanding the data models, connecting, creating reports, creating dashboards, say into a Power BI or a Tableau or a quick view, and there this now gets eliminated because we have built a semantic layer, and a conversation with the semantic layer will do the same thing that this group of engineers were doing. It is a industry changing or a pivot movement in the industry for BI especially, because what happens now is a CEO or a CXO or a marketing head will have a conversation with the system saying, can you list down my top 10 products for this month by sale? And this conversation will get converted into SQL through the semantic layer, gets executed at the data warehouse or lakehouse, response comes back, and then that response is again converted into a English language for the person to understand. And to the extent the leaders can then say, okay, can you create a chart of out of this information, and this conversation AI can do this chart. Now this semantic layer becomes very important for such use cases, and this is the trend we are seeing. Now, second point, Arun, to your question on the data management side, this is one aspect of data management. Right? The second aspect is, which means my master data has to be understood at a business level, which means my reference data that I'm bringing into the organization has to be understood at a business level, and which means the business teams becomes more directly ingrained as a data organization than data organization being run as a silo. We have built a data lake, someone will use the data, is no longer true. It is going to be driven from a business use case, which then backtracks and drives the data platform or data warehouse going forward. And this very much aligns with how we execute our projects with our customers, right? Where the focus is on solving a specific business use case and building an SSOT and a pipeline for that use case, which then eventually solves the business problem, than we building a large data lakehouse. That eventually happens that we end up building a large data lakehouse, but in due course of that, we would have solved like 20-30 business use cases. That's the viewpoint on data management with the AI coming in, Arun.
Amazing, Vipul. Again, going back in time, and we've been part of many battles as well. The entire experience of having to convert that data into insights used to be using certain tools, and there used to be certain norms. And what you're essentially saying right now is using a combination of semantic layer, conversational AI. A lot of that work is now getting AI-fied, and becomes a lot more easier, where business is starting to get a lot more involved. All right, now I think we'll now go into one common question that comes in all our conversations, right? Which is about security. More and more data is now flowing into these systems, various forms of data. There are data requirements, there are security norms, security considerations, and so on and so forth. How is AI helping today in keeping your data secure?
Great question, and one of the questions that many organizations have been focusing for at least the last 5-6 years, right? Though the generative AI LLM are very new, AI in risk, AI in security has been there prevalent for at least a decade now, and it is just getting more and more mature. What has happened in that spectrum is we started, so fraud analytics started with humans writing business rules or fraud rules saying if these 5 attributes change their value at this frequency, call it as a fraud or mark it as a alert. The next stage where we let the machine learning algorithms look at patterns, look at behavior of the data, call out, bring out anomalies, and then mark it as threats or red flags. That was the second stage. Even at that point, there used to be a human intervention to see what do we do with that red flag. The stage has come where ML algorithm, business rules plus ML algorithms plus an interface of AI which looks at these red alerts historically and then takes a decision on behalf of the human has become the norm in the industry, especially on the security and fraud detection areas. Where we are going to go even further with the agentic AI coming in, how do we automate some of these processes that we have set in fraud and risk will also become much more faster and automated. Said that, rules and regulations like GDPR, DPDP24, CCPAs, these have to be very cleanly understood, and a human intervention is always required to set up these rules in the system, either through a business rule or through a pattern matching rule. And this will continue to be a very focused, intensive, involved activity for our industry.
Perfect. Okay. Thank you, Vipul. I think now the audience probably will benefit from your perspectives of the future of data engineering, right? And we'll take a few questions on that. Maybe you can begin with Vipul on where you see data engineering headed in the next 5 to 10 years.
A great question, and a lot of engineers with this Gen AI and everything have started becoming wary. But I think this is an opportunity for data engineers and data engineering group as such, because what we need to now architect these databases to be more autonomous, right? How do we build these databases to self-optimize? How do we build these data attributes to be able to repairable without an human intervention? These are things that many of the products are already there. In fact, Oracle has their autonomous database, Snowflake AI database is there. But how do we data engineers understand these concepts and build these databases and model them in the right way will become a very critical part. Now, what will also happen with these autonomous databases is there will be a lot of performance tuning that will be required, because you will have to constantly understand how this data attribute is getting optimized or repaired on its own, and then fine tune the data attributes in terms of split the value into multiple fields or merge fields, or uh, uh, put business rules that the profiling of the data field is very different, so that the AI optimization auto repair can happen very efficiently. So that's a skill set that we all will have to learn, right? Performance tuning is no longer a separate team. It becomes part of an engineer's life cycle, especially data engineer's life cycle. many organizations are now looking at AI first data architectures, right? That's what we have been discussing of late, right? Where it can auto optimize the queries also. There are companies which have spent millions of dollars and we have written like thousands of SQLs. Do we go and manually fix them, or do we use AI tools to automatically look at these SQLs, these queries to fix themselves based on a metadata driven architecture? To the extent the metadata driven architecture itself is being rewritten in a way where you do not have to manually understand every field, map it to a business use case. The systems are there are a lot of AI applications which are there, which goes into your database, they extracts all the information that it needs, maps it to the business glossary and creates a metadata for your system. So these are some of the trends we are seeing. Last but not the least is the ML ops and the AI ops, which is very prevalent today with so many ML algorithms and AI algorithms being written, for which the pre-step is the data ops. How are companies setting up their data ops, right? How are we innovating to make sure that the data is always right for it to be converted into information? So there is a big opportunity which is going to be the data operations, and that will also increase the hyper automation of some of these databases.
Interesting, Vipul. Now that you've actually mentioned on data ops and ML ops, uh, maybe we can take a little bit further time, because again, the audience will be very interested in this. Can you elaborate on how data ops and ML ops as a field, how they are evolving?
Sure. See, data ops is becoming fundamental, because what's happening is a lot of these data engineering processes are required to be automated nowadays, right? A lot of streamlining is being done, and many of these activities, there are tools which help us do it very fast. In fact, there are tools like Monte Carlo, Datafold, which provide real time observability on the data, and it helps to detect and resolve data issues without or almost with no impact to the business, or very least impact to the business operations in this front. So
Interesting.
data engineers need to start learning and understanding these tools and aware of it. uh, Extending that from data ops to an ML ops story, um, today almost industry numbers have different numbers on this topic, that how many actual data ML AI projects go to live, right? It's not 100%, right? But the percentages are increasing, right? From a decade where there used to be 90 projects, of which only 5 used to go to project production, and I'm talking about EAML projects. We are looking at, of the 90, almost 40 going to production, right? Which means we need to now have a pipeline on which these ML algorithms can go into production, how the machine learning models can be monitored, how do we deploy them smoothly, how do we constantly look at the weights and biases which are assisting these models and make sure the models are always true to the data. How do we maintain model accuracy? How do we maintain or prevent data drift? These are things that are no longer a human activity. These are things that we need to automate, and that's where ML ops becomes much more important. The flip of it is when we don't do some of these things, and say in reality the data drift happens, the model just keeps giving us wrong projections or indications, the business may go in a direction which is not intended to go. And that's why ML ops is becoming very critical to a lot of organizations which are now dependent on these algorithms, AI models and ML models to run their day-to-day business. Arun.
Very, very fascinating future, Vipul. I'm sure there is a lot of promise in 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 what can be realized again in terms of value, and customers can benefit a lot if they do it right. How do they do it right? So if a company out there is listening to this podcast and they want to implement an AI driven data management approach, where should they start?
Excellent question. And this is something that we have been constantly working with our customers. In fact, I'll give you a customer example itself, right? We're working with a large automotive organization who have already built their data warehouse. They have like trillions of data in terms of huge amounts of petabytes and so forth. But how do they become AI ready? How do they move from this data warehouse that they have built to a AI ready? First thing is we look at their infrastructure, right, and identify if there are any bottlenecks which are already set in this data warehouse. How has the data ingestion pipelines been built? Can I have a much better data ingestion pipeline which can identify changes in the data attributes and fix its own self? So step 2 is to identify these data ingestion pipeline and see if they are auto fixable in terms of can they fix on their own. If they can't, what is the architectural change we need to build, or what is the intelligence we need to add to these pipelines so that they fix on their own. As I said, semantic layer has become fundamental key to some of these success stories. And what we are saying is we can do an independent semantic layer build out, which is not inside your data warehouse, which is not in your BI layer. But that's a long-term approach for sure. But to start off, the best way to start off is use your metadata tools that you may already have, or use your BI tools which already have a semantic layer inbuilt in it, right? For example, Power BI, Tableau, DBT, these all tools we already use, already have a set of or a level of semantic layering that we can set it. They may not be completely they may not completely replace a semantic layer end to end, but they will augment that to start off with. Similarly, so that's on the governance side of it, right? Security, there's a lot of AI powered anomaly detection tools which are in the market today or can be built using your own algorithms, and that will help you to reduce the impact of security. We did talk about the conversational AI that can literally replace business intelligence in a very different way. It is still in a nascent stage, but that's a watch out for all of us as an industry to see. How do I replace that 14,000 dashboards that we have built over decades with giving users a conversational platform and through that building out these reports? Lastly, as we just talked about data ops and ML ops, that becomes fundamental to all of these approaches. So just to recap, look at your architecture, look at your data pipeline, set up the right governance using semantic layer, do the right security activities, and then all of these put it on a pipeline which is data ops or ML ops, so that this can be repeated on a day-to-day basis with lesser impact to any business challenges or disruptions.
There you have it, folks. Great roadmap, just 5 steps. And then once you structure it in a proper way, you will be able to realize value. So, Vipul, with that, great roadmap, great conversation. Any final thoughts?
So yes, and this is something that we all hear every day, right? AI, Gen AI, LLMs, and so forth. These are no longer buzzwords, right? This is reality, right? And this is changing the way businesses work. This is changing the way that we have architected our databases and data management setup over the years. Now, how do companies embrace it? Yes, we will have to go to the drawing board and think of fixing some of those things, but not as a big bang. The best approach, and we have, as an Altimetrik, we have been following this, is look at what are the top 3 or 4 use cases which we want to invest in the next 1 or 2 years. Take those use cases, fix your pipeline from the point of data ingestion all the way to intelligence and usage of that intelligence. See if you can fix that specific fix everything for that specific use case, and then slowly move to the next use case and next use case, and eventually you will have a system which has adopted to the AI world. Again, start small but think big. That's been the mantra, and the future of data is going to be autonomous, scalable, and will always going. Now it will be only AI driven in future. Thank you, Arun.
Great insights, Vipul. I think it's been personally for me a great learning experience, and I'm sure all the listeners to this podcast also would benefit a lot from your rich and valuable insights. Thank you once again, Vipul, for joining us today. And to our listeners, if you enjoyed this fantastic discussion, don't forget to subscribe and stay tuned to even more episodes from Altimetrik of Beyond Next. Until then, goodbye.
Goodbye, team.